In this video, we will look at 3 more examples on chemical equilibrium. In this case, we are looking at using initial concentration to calculate equilibrium concentrations. So that's what we will be targeting in these 3 examples. So the first example is looking at predicting equilibrium concentrations from initial concentrations and equilibrium constants. So for you to do this, you need to know the initial concentrations. Those are concentrations at the beginning before equilibrium. And then you want to find the equilibrium concentrations. So let us consider this reaction. We have nitrogen here reacting with oxygen to produce nitrogen monoxide. So this reaction is at equilibrium. The Kc of this reaction at 2000 degrees Celsius is 0.10. This reaction mixture initially contained 0.2 molar of nitrogen and 0.2 molar of oxygen. So that is before the reaction, which means it did not contain any nitrogen monoxide at the beginning. Find the equilibrium concentrations of reactants and products at equilibrium at this temperature. So for this reaction, we are given the initial concentrations, but we want to find equilibrium concentration. So to solve this, we draw a table that we call ICE table. Initial concentration, change in concentration, and then the equilibrium concentration. So in short, it is known as ICE table. So I am going to draw this ICE table to show you how it works. So I have my table here. One, 2, 3, 4. So because I have 2 reactants and 1 product, so these will take 1, 2, and 3. Now I'll draw my line here. I start with this reactant. Here the concentration of my reactant here, the molar concentration of the other reactant, the molar concentration of the product. So that's what I'm looking at. Now, what was the initial concentration? So based on what we have, at the beginning, we had 0.200 molar. So if I indicate my concentration as this, I mean it is molar. And we also had 0.200 molar of oxygen. But initially, that was before the reaction started happening. We did not have any concentration of nitrogen monoxide. So for this one, we are going to put 0.000 molar. Now, what was the change to bring us to equilibrium? So what we do, we say, let the change in concentration be X. Maybe let the change in concentration be X. So if I can go back to this chemical reaction, 1 of nitrogen reacts with 1 of oxygen to give us 2 of nitrogen monoxide. So within that time, there will be a change in X. This nitrogen is going to lose a certain amount of its moles to give the product. The same thing with this oxygen is going to lose a certain amount of moles to get to the product. So it will lose some concentration to get to the final concentration. So really, the change we have here will be a minus X because it is a reactant, it is losing this concentration. The same thing here, the change will be minus X. It is a reactant, it is losing. Now, what do we do with the product? If you go back to this equation, you will see that for every nitrogen, we are producing 2 nitrogen monoxide. The same thing, for every oxygen here, we are producing 2 nitrogen monoxide. What it means is for every X we lose here, we are gaining 2X. So why am I putting 2 here? Because I have 2 here. So the coefficient is very important. Why did I put 1 here? Because in front here we have 1. The same here, in front here we have 1. Here this is 2 because in front here we have 2. Here we are losing, that's why I have minus here. The same thing, we are losing, that's why I have minus here. This nitrogen monoxide is gaining because it is being formed. That's why I have plus here. So I will draw a line separating initial and final, and also separating change. Now, what would be our equilibrium concentration? So our equilibrium will be 0.200 minus X. That is after we add this and this. The same thing here, 0.200 minus X. Now here you add 0.000 plus 2X. The answer will just be 2X. So that is the equilibrium concentration. So let me proceed. I will write the equation here again. N2 gas plus O2 gas equilibrium 2NO gas. But from here, we are saying these ones. This is the final concentration of N2, final concentration of O2, final concentration of NO2. So if I go forward again, we'll say that at equilibrium, the concentration of N2 is equal to 0.200 minus X. The concentration of O2 is equal to 0.200 minus X. And the concentration of NO is equal to 2x. Now, if we come back to this equation, we'll see that Kc is equal to the concentration of nitrogen monoxide divided by the concentration of nitrogen and the concentration of oxygen. So what we are going to do is just to substitute this concentration by these values here. So nitrogen monoxide, we have 2x, but this is squared. Down here, we have 0.200 minus x for nitrogen and 0.200 minus x for oxygen. If we continue, we are going to have 2x. Take note that I'm putting the whole 2x in parentheses, which means this square includes both this and this. Divided by this times this will give us 0.200 minus x squared. So that's what we have. But if we go up here, we know that Kc is equal to 0.10 at that temperature. So we'll say 2x squared divided by 0.200 minus x squared is equal to 0.10. Now, if you take the square root of both sides, this squared will be gone and we'll have 2x divided by 0.200 minus x will be equal to the square root of 10. Now, if you want to get rid of this square root of 10, You multiply this side by 0.200 minus x, and you do the same. You multiply this side 0.200 minus x. Just put it in parentheses. Once you do that, this will cancel with this one. So your 2x will be equal to the square root of 0.1 times 0.200 minus x times the square root of 0.10. So I'll continue it this side. So that will be our 2x. Now we want the x's to be on the same side, so we'll transfer this one to this side. So we are going to have 2x. When we transfer this to this side, it becomes plus 2x plus x square root of 0.10 is equal to 0.200 square root 0.10. This means there is a times here. Now, because we have x here, we can remove x from our parentheses. So x can be outside. We are going to have 2 plus 0.10 is equal to, you just need to multiply this times this. You get 0.6324. So you add this and this. You have x 2.3163 is equal to let me do the calculation again to make sure that I got 0.2 times the square root of 0.1. All right, so let me change here. To make sure that I got a correct answer. So this one 0.0632. So the same here, 0.632. Now once you do that, you want x to be by itself. So you divide both sides by 2.3163. The same thing here, 2.3163. Once you do that, your x will be 0.027. So this is the change in concentration. The change in concentration is 0.027 molar. But the question is asking about what is the equilibrium concentration. So if we go back to our equation and our concentration, we said that the concentration of nitrogen was 0.200 minus X. The concentration of oxygen was also 0.200 minus X. And the concentration of nitrogen monoxide was 2x. But we know that x is equal to 0.027. That's what we have calculated. So our equilibrium concentrations are as follows. So for N2, we are going to have 0.200 minus 0.027. molar, which gives us 0.173 m. For oxygen, the concentration will be the same, 0.200 minus 0.027, 0.173 molar. While for nitrogen monoxide, the concentration is 2x, so that would be 2 times 0.027, which gives us 0.054 molar. So these ones are the equilibrium concentrations. So make sure that you watch this video like again and again to understand what we are doing. And the next video will deal with another example. Thank you.